Quality check.
All right. Here we go, kids. We did it. How you doing, Campbell?
Good.
You good?
Yeah, I'm good.
All right. So, what was going on last time? What did we do last time?
So last time we were estimating the volume.
What happened the last time?
That was my fault. That was not a pro move. What I just did. Hit the
So
button.
last time we were estimating the volume of a sphere using a bunch of cylinders.
That's right. Uh-oh. Speaking of not pro moves, it's pudding! It's the pudding show. Seems like every day he takes over and it's his show.
And so you can press the up arrow key or down arrow key to increase or decrease the number of slices in your sphere.
Right. So it's looking, it wasn't looking good. We had to leave.
There's overlay.
Because the mom came into the room. And I'm thinking it's the slices. It's either our positioning or the width of the cylinders is too great. But there seems to be clearly a problem on here.
So right now I changed the code a bit so that I can hold the up arrow key down. And I added a rigid body to the slice prototype. And right now I'm trying to crash Unity.
All right. Because, sometimes that's what we do. So you added the rigid body because you wanted to put an impact on the physics engine, I guess, right?
Everything is saved except for the adding of the rigid body. So that it's just... I don't have to.
All right. So Campbell's trying to crash. Meanwhile, back over here on
really
my machine, we're going to investigate this. I'm going to create a new material here for the cylinder. And I'm going to make it a distinct color. Let's do this. From everything else. So I'll make it red. And I'll make it transparent so we can kind of see through them a little bit and see what's going on. I'm going to take that new material. Let's rename it. Call that the cylinder mat. Drag it onto my slice prototype right there. And let's try and let's save it and run it now. Checking in on Campbell's machine. He's at about 637 right now. He had it earlier without
a rigid body, and it got to 10,001, and it didn't crash, but it slowed down.
Does that mean you hit the up arrow key 10,000 times?
No, I just held it down. I changed the code a bit.
Got it. Okay.
Up arrow key.
All right.
Down.
Back over here to my machine. I'm going to hit the up arrow, and now let's take a look. And yeah, it looks like these are all way too wide. This one looks super wide, but it's actually two next to each other. So it looks like our width is maybe I want to guess it's twice as wide as it should be. That's what I think it is.
Yeah, it does. It definitely looks like that.
Let me make that change and see if that fixes it. So let's go figure that out. Let's go look at the code. This is the code we wrote about a week ago.
So slice thickness just divided by 2.
Yeah, I want to see what's going on with slice thickness here. How we're calculating that. We're taking diameter divided by slice count. Which would, I just want to make sure I understand why we want to cut it in half. That's how many slices? Yeah. The problem is, I don't think this is exactly right. The problem is our call to add cylinder creates one slice here, then creates another one at the negative position if we're not at the center. Okay, so because of that, we're going to always have an odd number of cylinders that we're going to create.
Yup. Cluckety cluck. Yep.
So my slice count is actually going to be this times 2. Let's do this. I'm going to create a variable here called total slices. And that's going to be equal to my slice count. Well, wait, hold on a second. If slice count is 3, diameter divided by 3, let's go back and look at this again. Hold on. If slice count is 3, let's go to 3 right there. There's slice count at 3. I get 1, 2, 3. So why are these so wide? This is the diameter divided by 3.
Would be a third of it.
Yeah, the slice thickness should be right.
Oh, wait a minute. Maybe in our slice count, maybe we're not counting the center. It's a slice. How do we know what slice count is?
Slice count is set by the key press. So
okay, so at the beginning, is it 1?
Yeah, what I don't understand, I understand that based on what we're looking at, we should change it, and it seems like we should change it, cut it in half. But I want to understand
Why?
it. That's what I'm kind of going for here.
What is the initial slice count value? Is it 3?
The transform local scale, wait, what is it? Yeah, it's 3. When I said it's 3, like, watch this, look. There's 3 right there. And so you can see there's the 3. I've got 1 on the left, 1 in the middle, and 1 on the side. But the scale from here to here doesn't seem to be a third of this diameter at all. It seems to be like even more than double it.
Well, then I do not know.
How am I getting the diameter? Yeah, sphere local scale is set to the diameter.
It's the radius times 2.
Can we set it here?
It's definitely slowing down.
Each time you're hitting the key, it takes like a few seconds. Okay.
Yeah, I'm holding it down even if it's taking.
We got this called a create slice with the slice thickness in here. We set the local scale again.
It's taking 7 seconds when I'm holding it down to increase.
Well, yeah, I am not at a point where I'm understanding why this isn't working the way I'm expecting it to work. I'm wondering about this line here. I'm going to comment this line out for a second. Excuse me. Sorry about that, kids. Let's try again. Okay, no change at all. All right, well, let's just try it. We'll try cutting it in half. Pudding says, bless you.
I'm not sure.
What'd you say, Kimball?
I'm not sure if that will help at all, actually.
Not sure what'll help.
Dividing it by 2.
Well, let's just try changing it to radius divided by slice count. And let's see what happens. They look better in terms of their size.
A bit. They're still overlapping.
That's the overlapping though is because of the way that's a different problem, I think. All right, let's go after it. I'm trying to figure out. Yeah, I'm not liking it. I really am not liking it because the math says that the slice thickness should be the diameter divided by the slice count. Let's do this. Let's start sending some stuff out. So I'm going to do a console log. Oh, wait, is it debug log? I think is what it is.
I think it is debug log.
Oh, and I've only got it in your machine, not mine. Log. And that and that. Let's do diameter divided. Shouldn't it be circumference? No, definitely not.
1,000.
Definitely not doing circumference. We're trying to go from one side to the other and create just across the whole sphere. So that's what we're trying to do. So I want to just get what the diameter is, what the slice thickness is here. And I want to send out a message that we're in rebuild. Sometimes the debug logs it's not really super clear when reading them. So there and there. Then we're in add cylinder. And I want to do something else. I want to track how many cylinders we've added. So I want to create a variable here called num cylinders.
Isn't that slice count?
Added. Well, it's not slice count. No, it could be I. We could also use to some degree, but actually, no, it's not. So num cylinders added. I'm going to set this to 0 here. Whoops. Set to 0. Come on, S0. Set to 0. Then into add cylinder and create slice. I'm going to increment it like that. And then I'm going to put out a debug.log here as well. That's going to say, just going to say what num cylinders added is. We're going to say adding slice, and then we're going to put in num cylinders added. So they'll say adding slice 1, 2, 3, 4, that sort of thing. Now that we're in that point, we're setting the transform's local scale to the slice thickness. I just want to kind of just again say what it is. Slice thickness is that. I'm almost suspecting it's a problem with scale and local scale and something else about it, but I'm not sure what that is. Like, for example, in our prototype, I'm not sure, but I'm wondering, our prototype, we've got 0.5 here on the Y. I wonder if this has any impact on it at all, Campbell. Do you think it does?
No, I don't.
Back to Campbell's machine over here. He's actively working 977. I think that's your focus now. I'm trying to solve the problem and you're trying to break things. Just to be clear, that's okay. That happens sometimes on the show. Let's see if
I can hold it down while it's still.
I'm going to change this to a 1 and just see if that has any impact on it. We'll go ahead and run it now. Had no impact to change it. Let's go look at the console. So what's our radius? We got something up here. Our diameter is 100. Our slice thickness is 20. That's a surprise.
But our radius.
Oh, that's for 5. That was for 5. Hold on, that was for 5. We're okay.
Okay. Okie dokie.
Let's get down to where we had it. Diameter, there we go. Slice thickness 33. Adding slice 1, slice thickness is 33. Slice 2, it's 33. Slice 3 is 33.
But that's for a radius of 90.
What?
That would be for a radius of 90 when our radius is 50.
No, it's a radius of 100. Oh, no, it's a diameter of 100.
Oh, wait. Sorry.
Diameter of 100 divided by 3 is 33.33. So the numbers are all right. This is just looking ridiculously bigger. If that's 100 from here to here, why does that slice, right? Why is it so big? And we should... and we're only adding 3 slices. We can see the counts right there, 1, 2, and 3. All right, I'm going to throw this at it. I don't understand why this would work. I'm throwing it there, and I'm going to do a divided by 2 here as well.
Wait.
You look confused, Campbell. What are you thinking?
I am confused on why just everything that's happened. Not this. But
Not this? You're confused by
Yeah.
this? I just want to see what happens if we cut these in half there and see what it looks like. Well, certainly positioning looks better, but look, it's still, divide by 2 is not actually what we want. It's still too big. It's as if this divided, it's like, I don't even get this. Are we setting our sphere to the right? Maybe our sphere is wrong. Let's look at the sphere for a second. My sphere scale is at 1, 1, and 1. Did we ever change that?
Yeah, transform sphere.
We do it on the start, based on whatever the diameter is set to. And the diameter is set to radius times 2. So our radius, when we start the game, is
Try
50.
increasing the slice count a bit.
Hold on, I just want to change it to 30 and run it and see if we're still running into the same kind of proportional issues. Yeah.
Yeah. I think.
Oh wait,
It is.
it was an optical illusion. It is actually good. See it?
Yeah.
It's just, it looked like it was, because it was transparent, it looked like it was sticking further out than it was. It does not appear to be doing it. It's lined up exactly right. Okay. Yeah, it's just we've got a very wide angle lens is what's happening on here. All right, so that's good. We're actually in kind of like it's working, but we kind of don't know why. We have to do this right here. That's the fix. Or sorry, this one right here is the fix. The local scale.
Maybe we don't.
Tell me what you're thinking.
Try not deleting the divided by 2 on both of them, and I think we might have had it before and we were just seeing it.
Oh no, I don't think so. It was sticking out pretty far. Take a look at it. See it?
Oh yeah.
And also we've got the overlap on the insides too. So there's
Okay.
something I'm not understanding about that scale, that if I set the scale to this amount, it seems like it's doubling it almost. And I don't get that. I don't understand why that's the case. I'm going to put a little to-do comment up here that says, I don't get this. I don't get why we need to cut slice thickness in half here. It's as if the Y.
Well, I've got an error message.
Yeah, what you got? Show me.
Due to floating point precision limitations, it is recommended to bring the world coordinates of the game object within a smaller range.
All right, so at about 1,000.
Woohoo!
I'm going to call that, as close to a crash as you're probably going to get. Well, I don't know. You can keep trying. It's as if the Y scale
Wait a minute.
is doubled.
Dang it.
So I'm going to create it, and look what I'm doing over here, Kimmel.
Yeah?
Y scale fix is equal to, I'm going to make a very, very obvious change in the code to show that I don't understand it, and that I've created this Y scale.
Yeah, it does make zero sense.
But the point I want to emphasize is, yes, I agree it makes no sense, but what I'm doing is I'm documenting that it doesn't make sense with a variable named fix. Mm-hmm. Okay? That's what I'm doing. We don't need the debug logs here anymore. Yeah, all the math was working the way we were expecting it to work. Okay, So with that, num cylinders added. We don't need that anymore. That was all for debugging. And now I've got create slice and rebuild as the fixes. I'm going to bring these over to your machine. Can you stop what you're doing and we'll paste those in?
No, I cannot.
Really? Yeah. So this is me. Wait, let me go back. This is Campbell. I'm going to try and crash my machine live.
Oh.
This is me. Live? You want to crash it?
Okay, it worked. Everything's fine.
All right, give me to the code.
To the code.
Okay.
Okay.
I think it's these two.
I'm good with
Rebuild
that.
and create slice is what I believe. In fact, let me just look at these for a second here. I took out this because it seemed to be doing nothing.
Okie
That line
dokie.
right there. And I added this.
Yeah.
Essentially right there.
Divided by 2.
That's it. Well, I actually did this. Let's go ahead and I'll give you both of the methods so you have them both.
Okie dokie. Whoop.
Okay. And I've added this to-do comment here, which basically is like allows us to later maybe reinvestigate it. Allows us to kind of move on and investigate later. So try running it on your machine and see how that works.
All right. Wait, there's also one more thing I have to do.
What are you doing?
Fixing it so that I can't hold it down.
Oh. Control space right there will fix it for you automatically if you want. All right, here we go.
Whoa. Oh wait, they still have rigid bodies.
Added rigid body. Someone was trying to break things, I think.
I was.
Why weren't they?
Falling
Why weren't
apart
they?
before.
Why weren't they all falling before when you were doing it? I
Not sure.
Okay, you don't know? That's weird. All right, so down arrow, get the 3 and look at it carefully in the camera. Look at the edges. Make sure the edges are lined up.
Appears to be working.
Yeah, that looks good. So it's just the right size. Next, we need to actually add up.
But here's the thing.
The
It
volumes.
looks like it's overlaying here.
Look carefully at it. Align the camera. I don't think it is.
Yeah, I know, but it looks like it, so that's a bit confusing.
Well, it's just because we've got translucent pieces there.
Yeah.
All we need to do is verify that it's not, and we're good, because the purpose of this is really now, next step, which is we want to sum up the volumes of all the cylinders and see what they are. See what's going on? You're seeing the sphere peek through.
Oh. But if we make it bigger and or more pieces and more pieces. Huh. So maybe we should make the sphere a bit bigger then?
Nope. I don't want to do anything.
Okay.
Because I think our math is good. Because remember we used Pythagorean's theorem to figure out how big the cylinder should be?
Yes. Yeah.
So the math is, if the math is right, we shouldn't go making adjustments on the sphere to make it bigger or something like that, because we're trying to actually fill it in.
On this sphere.
What?
On the transparent one.
Right, the transparent one is set to whatever the radius is that we set. I mean, you can do it, but now all of a sudden we're not trying to estimate, we're not visualizing the piece we're trying to estimate.
Okay.
Right?
All right.
What's interesting is the more you do that, kind of the more of the sphere we start to see, because it starts to filling in and the less of it seems to be obscured. All right, so now the challenge, Campbell, is
actually estimating the volume, adding
right.
up with some.
Do you remember the formula for the volume of a cylinder?
Yeah, it's area times height.
Okay, so can you get me a method that gives me the area of a cylinder, the volume of a cylinder, given its radius and its height?
Yeah, I think so. And where would we call this method?
What would we call it? Well, you can
No,
decide
where?
that.
Where would we call it?
Where would we call it from?
Yes.
Well, I'll let you figure that out too. The first thing we're going to do, and we've got this great music in here, this challenging music here for the challenge. The first thing we're going to do is we're going to create a method that returns a float. To do that, you want to type in the letters
Float.
MF, method that returns a float.
Space. Method name.
You got one L.
Cylinder volume.
Right, I would have put the word get in front of this. Get cylinder volume.
Okay.
All right, hit enter.
Enter.
Now you want to have a parameter. Oops,
Oh,
go back up there. You want a parameter in here. That's going to be a float, which is going to be your radius.
Yes.
So type in VF.
A variable type float. And then radius.
Sure. And get one more parameter in there, which is going to be your height. All you have to do is hit a space now. And type in VF again. And now call it height. Okay, cool. And then down in here, we want to return that volume. So we're going to use the keyword return. I think this is the first time we've actually created a method that returns a value. So down inside the between the braces, it says not all code paths return a value yet, and we're going to do that. So down here, we're going to type in. If you just hit R in the space bar, the coders will give you a return, and then now you can put your formula in here now.
So this in here.
Yeah, whatever you put here is the value that will be returned from this function when it's called.
We need math dot. No, not pow. Oopsies. Pi.
Okay.
I'm guessing.
Okay. Yep, that's good. You got math.py. Did you know how to do times in code?
Yeah, it's.
There you go.
And then radius. Oopsies.
You want to copy that math.py and put it before, I think, the radius is what I think you
Oh,
want to do.
is that what you have to do?
Yeah, it's math.py is a function that takes two parameters. And I think pow needs an uppercase. If you hit control space inside pow, if you put the caret inside pow and hit control space, autocomplete will finish it for you with the right case. Just hit control space. Okay, it's good. It's just, I think you're missing a parameter. So you have one first parameter, which I think is radius. The second parameter is the power.
Oh, yeah, okay. 2.
Okay. You have a problem, I think, in that the math.pow is returning a double and you're returning a float. And a double times anything is going to be a double, I think. So what you want to do is go before that math, the first math there, and I'm sorry, right there in pow, yeah, there. Type in CF. C for cast, F to float.
Oh, so that it returns a float instead.
Yeah. And math.py might be a double as well, now that I think about it. So you might do a CF right there as well.
No. CF.
Right there, and that might fix that underline that you're looking at.
Yeah.
There you go.
Okay.
Okay.
Okie dokie. I'm actually gonna do this. Dot.
Introduce local.
Yeah.
Down, no, down below.
Oopsies, yeah. And then I'm gonna call this area.
I'd suggest local variable start with a lowercase letter.
Oh, oopsies.
Blueberries is out there. Hey, Blueberries.
Hello.
Thanks for your help, kids. All right. And
then
well, return area. It's return area is the last thing that happens here in this function. It's out when it sees return. It exits the function. So you're gonna make any changes you need to make are right here in this expression that's returned.
okay. So this is times.
No, not there. Because you've already assigned this to area. What I think you want to do, yes, is there. Multiply area. Does that make sense? And I like what you did there. I like how you kind of simplified and created an area first.
Yeah, it was just a lot, and it didn't necessarily. I felt like in the future we wouldn't make as much sense.
Yeah. So it's a lot, and now we've got it. So
And
now
now
we've got
it's just
pi r
boop.
squared. What'd you say?
And now it's just there.
Now it's there. So we've got now something that calculates the cylinder volume. We need to track the cylinder volume.
We do.
Okay. We need a variable that's going to track it, and we need to reset that variable whenever we rebuild. Yeah, Blueberries also agrees. Good intuition on readability. Excuse me. Yeah. Agreed, Blueberries. So this is something I think where we're about to do something that I think is not entirely clear in your head right now. Is that true, Kimball?
No, not necessarily.
What to do next is it clear in your head what to do next?
Kind of.
Okay.
So
go ahead. Let's
I
follow
just
what you
don't
want
know
to do.
where to call it from. I know that when we do call it, or this is what I think, in the parameters we're going to put the radius here, the original variable radius, and then here we're going to do the thickness,
Yes.
slice thickness.
Yep.
And
I agree.
then,
So we needed to call it,
so
but we
for the
also.
cylinder volume,
But what I'm getting at is we need to call it many times, and we need to track it, the value as we're calling it each time, because we need to add up all the values, right?
yes.
Think about the big picture. We need to get the estimated volume of the sphere. So how do we do that?
Every time we instantiate one, we're gonna, we're gonna call the method.
Right. Yeah, I agree with that. That's not it. So you want to find that? Where are we going to do that? Once you find the place where you want to call it first. All I'm trying to do is trying to lead you to the idea that you're going to need a variable to hold on to the value as you accumulate it. That's what I'm trying to get you to realize. That we're going to need a variable at the beginning of our process that's reset to 0. All right, so you're inside create slice.
Actually, I think it's gonna be right there.
Going to be where?
After add cylinder.
In add cylinder. Notice what add cylinder does. Look at lines 42 and line 44. Tell me what's going on with line 43 and 44.
43 and 44, they determine if the x position isn't the center, and if it isn't, then you create slice on the negative x position.
Right, so we always have a slice in the center, and then we have 2 on either side. Your intuition says put it in add cylinder.
Well, now that you've stopped me from doing it, I think.
Good intuition. I love this new intuition that's responding to the stopping you from doing it. The reason why is because add cylinder sometimes creates 1 and sometimes creates 2 slices. And so you can put it in add cylinder, but your code's going to have to follow the same structure.
Yes.
But we can keep add cylinder simpler if we instead put it in create slice. That's what I'm trying to suggest.
Yeah, right
Because
here.
slices, no matter
No.
how many times we call it, this is where we're actually going to need to add it up and create a value.
Right after we instantiate. Or at the end. It doesn't matter, does it?
Nope, it doesn't matter. You can put it at the beginning or the end, anywhere you want in here. It's just as long as sometime inside of here we got to get that cylinder volume and pass in the radius.
What's wrong?
What's wrong? Well, you just pasted that in there. The float on the left is, it's not quite syntactically right yet. You need to pass in parameters to it.
Oh, right.
And I don't think, we haven't really worked with methods that return values yet. So the radius is what? Do we have a radius in here?
We do, I think. Wait, let me just.
Nope, no. That is the radius of the sphere.
Oh, right.
We need the radius of the slice.
Of the slice, yes. No, but
Look in this method. Do we have the radius of the slice in this method?
No. Wait, yes. We have cylinder diameter.
Okay, so let's take it. How do we get radius from cylinder diameter?
It's cylinder diameter divided by 2.
Yeah. Good. What's going on with
wrong.
height?
Oh, it's slice thickness.
Okay. Let's throw that at it. Autocomplete isn't kicking in. I think it's because of the word float off to the left because it's not quite syntactically correct. It looks like you're trying to declare a variable maybe, and you're missing something there. Now hit control space right there.
Okay. Slice thickness. Boop.
Okay, good.
Wait, but why? Every time we call a method otherwise, we have void.
Yeah. But look at our get cylinder volume. Go put the caret in get cylinder volume and hit the tab key. Look at how it doesn't have a void at the beginning of it.
Yeah, but aren't they the same?
See, it's got a float, and it's got the return keyword with an expression after it on line 95. See it? So let me show you what you can do with CodeRush. Go back up, hit escape to go back to where you were. Go to the, oh yeah, I think you can do it now. Hit control dot.
Control dot.
Choose to declare local. And you're done. Cylinder volume. So now you've got a local variable that tells you what the volume is of this particular slice we're adding.
Yes.
Now, what do we got to do?
We have to make another variable that stores all of the cylinder volumes that we add to it.
Yeah. Yeah. Blueberries is asking, are return values totally new to Campbell? They are. This is the first time we've used them. First time we've used return values on functions. First time we've created a function that had returned a value, I think.
No, not that I remember. I feel like we
All right, so Campbell says that they're not totally new, but look at...
No, they're pretty new.
This is the first time you've written a line of code like this, though. Would you agree with that?
Yeah.
Line 57? Okay. Right, because you were looking at it and you were like, wait, what, void? And it seemed to be interesting to you, right? That seemed it looked like you had never seen that before.
Oh, are you talking about methods that return?
Yeah, that's what I'm talking about.
I thought you were talking about these.
Oh, the return statement. You've seen return statement, but we haven't created a method that returns a value before.
No, never.
Remember we used M for method and F for float to build it. Okay, so we want to now create a variable that's our total volume. Maybe we call it total volume. Do you agree with that?
Yes.
Let's put it close by here, because I just want to be able to see everything on screen. So let's do it not in, not in the method. If it's a local variable in the method, local variables are always reset every time the method is called. You can put it up here, but I kind of wanted to put it, you can put it up here if you want.
I just like it because all of them.
That's fine, totally fine. You could duplicate line 12 if you want, and just call it volume, total volume. And this one won't be public though, actually, now that I think about it.
Well, no big deal.
Total volume.
Sphere.
Total sphere volume.
Because it might be confusing. You might confuse it with the slice that you're on.
Well, it is the slice volume. It's not really the sphere volume. I think we should call it total slice volume, maybe.
Why?
Because we're adding up all the slices. It's the total of the slices.
Yeah, but all of the slices combined create the sphere volume.
Right, but I think we're going to separately want to calculate the actual sphere volume using the actual formula so we can compare and see how close we are.
You're right, you're right, you're right.
Well, I don't know if I'm right or not, but it's something to consider. All right, total volume.
Well, okay.
Now, we need to figure out when we change it. When do we change it?
We change it down here. In this method.
Okay.
I'm just gonna do it like here. Total volume plus right?
Plus equals. Plus just increments by 1.
Plus equals cylinder volume.
Yes. But cylinder volume isn't available for you right here.
Why?
Because look at line 58. You haven't declared it yet till 2 lines later. So your line 56 is happening too soon. You have to have you have to first calculate cylinder volume and then change total volume. Does that make sense?
Yes. Yes.
It's total volume, I think, right? It's the line you started to type. If you have it on the
Oh, right.
clipboard,
Sorry.
you can paste
Total
it.
volume.
There you go. It's suggesting it for you.
Plus equals
Yeah.
cylinder.
It's down 2. You got it. Don't
Oopsies,
forget to look
caps
up
lock.
there and get that suggestion because it's almost always suggesting after a few keystrokes. All right, good. So there's total volume. Any other places we need to change total volume?
I'm guessing yes,
Yeah.
based on the fact that you said that.
That I'm asking. The answer is yes. There's one other place we need to change it. We need to set it to 0 at some place. If we don't set it to 0, when you change from 3 to 5, it'll just keep adding the volume. When you change from 5 to 7, it'll add even more. It'll just keep growing and growing and growing. We need to reset it at some place. Where do we reset total volume? And you're getting colder as you scroll up.
Is it an add cylinder?
Getting close. You're getting warmer. Getting warmer.
Oh, it's in rebuild,
It's in rebuild.
right? 'Cause
Yes, that's where it is. Nope, not in there though. Look at what you've done. You're in a for loop.
Oh, oopsies.
You'll reset it to 0 and you'll only get the last one. It has to be
That was
before.
not what I meant to
It
do.
has to be before you call add cylinder. Add cylinder is where it changes, right? Add cylinder gets you all the way in to that function up above, I think, right?
Yes.
Is it on the clipboard right now?
Nope.
Okay. The total volume. Shift end will select that whole thing for you if you want.
Plus equals cylinder.
Think about what
Oh
we're
wait,
trying to do.
oopsies. That is
Think about
not-
what we're trying to do. We need to reset this before we start totaling it up. We totaled it up because of all those calls to add cylinder. The reset is critical to make this work. And this kind of thing we're doing is a pattern. We do this all the time in code, where we'll take a variable like total volume, we'll set it to 0, and then we'll modify it like line 58. See line 58 right here?
Yeah.
We'll modify it inside a function that's called multiple times. See, look, add cylinder is called for every slice, right? Add cylinder calls create slice. So for every slice, we're going to come in there and get it. Now we need some text to show it. We need some UI text to show what the total is going to be, and we need to set it right here. So I'm going to put a to-do for you right in here. Set UI text to show the total calculated volume. Okay, there's your to-do. So right now, add some text. Add some UI text.
Okie dokie. My mouse.
Showing up right there, that new text in the bottom. Do you want to put it, where do you want to put it? I think we can keep it in the bottom left, actually, if you want.
Huh, I was thinking maybe the top right.
Okay, do it at the top right then.
Property right. It's why is this one? Yeah, that was right. Okay, now the X position.
Needs to be closer to 0. Why don't you set it to 0 and then drag the top position X? The fast way to do it, just set it to 0. But there it is right there. Look at it. Okay.
And then I'm gonna make
Turn off
it.
wrap and truncate. Yeah, it disappears. You change the font size because it's doing that. Change your, slide it over a bit. Oh yeah, make it right align. Alignment, make it right align.
It is.
No, right there, the button right above my finger. The under
Oh,
paragraph,
the text.
right there. Make it right align. And now get that position X, move it so it's on screen. Okay. Hold. Do this. Hit the eyedropper button right up there.
And then do this.
Yeah.
Ookity dokity.
Did you hit it? I don't think you hit the
I did.
eyedropper. Oh, okay. There's another eyedropper off to the side. I didn't see that one. Okay, cool. That makes
This
sense.
one?
I was talking about that one, but you got a different one. So you're cool. You're good. You got it already.
Cool.
I was just. It's okay. You don't have to do it a second time.
I was just experimenting with it. Nope, not the color I want.
The color right.
I did.
Okay.
And then I think I messed it up.
There's our new text. So we're gonna say calculated.
Everything is fine.
We're gonna call this like calculated volume or something like that.
Going off rails!
Going off rails.
Volume.
Okay, cool. Go
Yep.
back to the script, add a place for that. Add a property in the script and then connect the property and then set it. Just duplicate that, there you go. Paste, good. You can change it down in here,
Oh,
down
yes.
where we recalculate it.
Wait.
It's that total volume right there. Whoops,
Oops.
the A was selected. Hit undo. There you go. All right. Yeah, don't change it here. We might have 10,000 slices we're creating. Do it after all the cylinders have been added.
What do you mean?
Look at line 76.
Oh.
Right? Look at the for loop
Yeah.
above it. The for loop, that's when all the cylinders have been added.
How do we set the text again?
Dot text. It's on line 69. Look at line 69 right above you.
Oh, yeah. Huh. Text. Equals. String. What was it again? Calculated volume. Okay.
It's on line 70 as the variable. Oh, you're asking what to call it? Yeah, calculated volume. Now the cool thing about right aligning that, Campbell, is that that's gonna, you know, it
Always
doesn't matter
be
how
there.
long this line gets, it should still show up right in the upper right. Good. Good. Now you just need to connect that text element to the script and run, and I think it's going to work. Meanwhile, I'm going to get out my calculator, and I'm going to see what the volume should be and see how close we get to that volume. The radius up there you can see is 50. And the formula is like 4/3 pi r cubed. If I'm
Yeah,
calling-
4/3 pi r cubed.
we're calling correctly. So let me go pump that in here. 4 times, what's going on, scientific? Why don't I see my pi here? Where's pi? It's got to have pi here. It doesn't even feel
What?
scientific to me. Why is it? Oh my gosh, what's happened?
Why is there no pi? Volume. Try volume.
There's a volume option in here?
Yes.
No,
What?
no, it's a converter. Wait, where's pi? There's got to be pi here. Do I have to jump in here? Whoops. Just type 3.14. Yeah, okay, fine, I'll do that. All right, so let's do this. Campbell, you remember what the what pi is?
3.14 and then 159. That's all
159.
you really have to do.
All right. Times our radius, which is cubed.
Yes.
I don't even see an x. Oh, an exponent. Yeah, I don't know if I'm going to do that. I'm just going to do times 50 times 50 times 50
Times 4/3.
times 4 divided by 3. I think we're looking for 5,023. Man, this is the worst calculator I've ever used. I'm going to go grab my phone calculator and do it for real.
Huh?
Because
5,023?
Yeah, I got 5,023. Let's switch over to your machine. What are you at?
Uh-oh. So it does get a... Oh, wait. Maximize.
Go full
on
screen. You're getting pretty close.
Pretty close.
All right, so that's cool.
Even
At least we
with
got
just
that
3.
right. So
3 is pretty close as well.
yeah, 3 is close.
Kind of.
Let's see at 3.
Okay.
So we're looking for 5,023, 598 and a third. That's what we're looking for. So 3, it's not bad.
No. But then, the more we go...
Wait, it looks like you don't have the divide by 2 thing going in there. It looks like you got the wrong size on the width. Is that true or not? Can we go look at that? Look at your code, make sure you've got the divide by 2 still in there.
I remember...
When you were at 3, it didn't quite look right. Wait, scroll back up. It's an add slice.
Wait,
hold on.
where is that slice?
Y scale fix. No, it's, yeah, you've got the Y scale fix in there. You have it at 55. It looks okay. Let's try it one more time, just with 3. Go up and down. Go down to 3. Wait, make these translucent. I want to be able to see if they're right on the edge or not. Slice material. Can you move the camera? Oh, we can't move the camera. Here. I want to get to the camera view so we can get right on the edge. Because I think we're dealing with a wide angle lens. Good. It's good. Okay, you're good. It was an optical illusion. Man, that wide angle lens throws me. Okay, so cool. That's not bad.
I want to see if we can get, like...
How close we can get?
Yeah.
All right, so we're looking for 5,023, 598.
598?
Yeah, so you're dropping down.
Oh, we can do that.
You're looking towards,
Okay.
you're at 609,
Yeah,
607.
I think we can get to that.
How many slices you're at? You're about 200 slices. Sweet. Yeah, it's dropping in size. About
Come
300
on.
slices. How many slices is it going to take to get accurate
Enough.
to at least 1?
Well, we're gonna find out.
It's kind of jumping up and down.
It
It's kind of
is.
interesting. I would expect it to only get more accurate.
Me too.
That feels like a mistake somehow, and I'm not sure what it is. You're at
Aha!
400?
Oh wait, that's not close enough.
Not quite close enough. It's about 0.3, 598.3. And I'm really confused as to why is it popping up? Why does it get closer and then further away the more we add? The more we add, the closer it should be.
$598.5.
It's not bad with 500. Yeah, right now I think I can only wonder about it, Campbell. I don't have any explanation as to why it would jump up the more we add it.
Wait, 598.4.
That's pretty close.
607.
It's pretty close. But it still jumps up. Why is it jumping up?
I'm not sure. Oh, that's it. 691. But then it jumps back up again.
Yeah, that's interesting, isn't it? All right, let's change the radius of the sphere. And let's do a different test on it. Let's make it smaller. Let's make the radius of the sphere 10. Sphere 10. All right, so 10 times 10 times 10, that's 10 cubed. That's equal to 1,000 times 3.14159 times 4 divided by 3. I get 4,188.
Point.
0.78.
We probably got that.
It seems like it didn't take too long to get to you here.
No, it did not.
I'd like to look closely at what happens when we go from 1. Can we start it again? And I'd like to see what happens as we go from 1 to, from 3 slices to 5. I just want to see what's happening in the early stages of this. Are you just going to drop it down?
Yeah.
Okay.
Probably not the fastest way, but
That's all right. I like to visualize it too and see what's happening with the slices, right? Okay, so we're at 4, 4, 2, 1. Changing from 4, 4, 2, 1 to 5. Maybe closer? I want to see when we start moving away from the answer. We're trying to get to 4188. So we go closer. Yeah. Wait. I want to see each step. I want you to determine are we getting closer or further away from our number? We're trying to get to 4188.
Closer.
Okay. So that looks closer too. Okay. Closer.
Closer.
Wait, did we jump up? No, we went closer.
Closer. Wait, sorry, that was my bad.
Yeah, closer.
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 Closer. Closer.
What's interesting is we're
closer, but not by much.
we're trying to get 4188.
Bit
yeah.
closer.
So we haven't gone farther away yet, right? Is that right, Campbell? I haven't been watching carefully.
No, we have not. Closer.
So each time the number's smaller than the number before.
Closer. Yeah, closer.
Wait. I thought I saw 91. I think we may have gone away. There. So go back one more.
I did go. I was going back.
Oh, you were going back? Oh, okay.
Yeah,
All
sorry.
right.
Closer, closer.
There.
Yes.
No, I think
I
we
went
did.
back.
Oh, you went back. Okay.
Sorry.
All right.
I'll try to tell you next time.
No, that's all right. I'll just keep my mouth shut.
Yep. Sorry, I went back. Closer. 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 Wait, I'm going back.
You can also write
Closer.
software to solve this for us as well.
Closer.
You can write software that checks to see as we move increased slices, do we get further away?
Yeah, it's definitely getting closer. Yep.
It's also interesting that our technique for estimating by stacking up the cylinders overestimates. It always is overestimating, it seems. Like there's always some amount of area that's appearing outside of the cylinder. At least the volume outside is greater than the volume that's left in these gaps that we haven't filled in yet in the cylinder.
Yeah, because it kind of makes sense. If we're going boop, 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 those corners at the edge.
Yeah. Blueberry says top row second from the left. I'm like, oh yeah, there it is right there. I don't know why I didn't see that before. All right. Cool. Well, that was our goal.
Getting closer.
Is to kind of get into that space. Do you want to do anything with this? Make this bigger, so that we can kind of see it a little, or because we can't really zoom in the camera. I think from this view, we can't change the camera here. What's going on with your face? What are you thinking about?
It just was getting closer, but now it's not.
It's started getting further away.
No. Sorry, I worded that incorrectly.
What'd you say?
It's still going regularly. It's still getting closer, even though before it was getting...
Right, but we had to put a lot of slices in before.
We did.
Remember? Yeah. The total,
Wait a minute.
the number of digits of accuracy that we had before was, I think, about 8. Maybe 6. It was around 6 to 8 that we had before, which is a lot. Right now you've got 4 digits of accuracy, I think.
Yes.
4188.78 is what I have. So you're getting closer. Yeah, it's kind of a neat technique. It's super interesting.
Oh, that's it. We get further.
You just found one where you got further away.
So this is me going back and then closer.
So once we go further away, it's kind of interesting because it's like, why don't you do this for me, Campbell? Make it so that if you're holding down the control key as you do up and down, it
bounces 10.
It goes by 10 or 100, something like that.
Oh goody doop goody, lemon smoke goody.
I have a suggestion for making this simple.
Flattening the conditional answer.
What's the way to tell if just the key is down? This means it's pressed, right? It was just pressed.
Get key.
Get key.
Just get key.
So what I want to do is I want to say, if get key control,
And then
left control, then we just hit shift enter there, or right control. That was duplicate line there. I just changed that piece. Then I'm gonna come in here and I'm gonna create a new variable type float called multiplier.
Multiplier.
Weird popping sound here. So I'm gonna say multiplier is equal to 1. If that's down, I'm gonna say multiplier is equal to 10. Okay. And then
slice count plus equals multiplier. Also, multiplier should be equal to 2.
What'd you say?
Oh wait, never mind.
Yeah, that's what I'm gonna do. So times 10. And maybe I'm gonna do this even. I'm gonna say if you do shift, like that, Campbell. So if you hold control and shift down, we're gonna go to multiplier is equal to 100. But if not, we're just gonna say multiplier is equal to 10. That's what I think I wanna do with that. Try running that now, and then let's just go in there and let's also make the radius bigger. Let's make the radius like 25, something like that. I'll give you the deal with that. So it's pi. Clear.
Weird.
Pi times 4 times 3 times I'm looking for 589,000 is what I'm looking for. Oh, you didn't change? Did you change the volume to 25? The radius to 25?
Oh, no, I did not. I'll do that right now.
So for me, pi r cubed in my calculator is 589,000.
589,000. Control shift. Boop, 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 boop.
What did I do wrong? 4. Oh, I did 4 times 3. Hold on a second. Let's divide that answer by 3 and then divide by 3 one more time. I got 65,449.
449 point?
Yeah, so now you're at 4,000. It's 0.84. You're at 8.6. Try bumping this up to like 5,000.
5,000?
So control shift up arrow or down arrow. Okay. What are we at now? It's 65,449.5.
And it was, wait, 0.4?
I'm at 0.84.
0.84.
So it's a little low. 82. Wait, 449. Is it really, as you were, I didn't see what was happening to slice count. You're picking it up?
Yeah.
Let's take it up to 10,000.
Doopity doopity. This is control shift.
65,449.5. It's not, is where you are right there. 0.5. So it's pretty close. I've got 0.84. So we've got basically 5 digits of accuracy, about 4 digits of accuracy roughly. We keep bringing it up there. Oh, we got not a number. So we kind of hit the limits of our internal calculations. I am suspecting that the problem is with errors in the floating point space. That's what my suspicion is. Let me try errors.
We have errors. Those are the non-numbered errors.
Let's look at this a second. Let's talk about the difference between floats and doubles. So we'll switch over to my machine. What do we got over there? Input local scale is not a number. Oh, because it got so thin.
Oh my god.
I think.
That it became zero.
Yeah.
And it was trying to go to negative.
That's kind of what I'm feeling is the case over there.
So that was as precise as we could get, and it still wasn't correct.
Yeah, it was close, but yeah. I don't actually have a good intuition on what I think the problem is, Campbell. I don't know what it is.
Me neither.
What do you want to do next?
Maybe the problem is that since every time we're adding just a little bit of scale on the outside because of the corner, you know, we're going boop, 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 but like they're on a very small scale. There's a little bit of extra on the outside. And every time we add a slice, we add a little bit of excess. But we also make all the slices thinner and more precise. So maybe every other time, or every 2 times, the scale the excess that we've added outweighs that we have gotten rid of.
Yeah, it's kind of interesting, isn't it? Can I
don't know how to fix it, but I think that might be the problem.
Well, maybe. Let's come in here. Let's change this back to, I think it's like 60. And I don't want to maximize. I want to instead be able to play in this space over here. And let's run it. So I wanted to be able to move around here and look at
we should also probably move the camera along with every time we get bigger. So if the radius is 500, we can still see it.
So I wanted to kind of zoom in on the edge pieces here.
Yeah.
Right, see what's happening?
Those corners.
You can. What'd you say?
Those corners. That's what I was talking about.
Right. That's kind of what I wanted to zoom in because you were talking about that. I wanted to look at those with you. This isn't just happening here on this edge. It's happening all the way around in a circle for all of these.
Yes. Oh yeah. There's excess all around the circle.
Yeah.
It's not just on the
And then there's also there's excess, but look here. See this right here?
Yeah.
That's part of the sphere that we're not filling in.
Ooh, yes.
So what's happening is we're adding more of these. What's happening is this amount is getting smaller and the amount that's outside is getting smaller. So right now it's like this, right? It's this big. But if we're to, let's just keep the view here, come back over here and let's add by 100.
What?
Right? See what's happening?
Okay, yeah.
There's with, what is it? 17 and there's with, it's like, is it 217 or something like that? Yeah.
Mm-hmm.
So we're jumping up pretty quickly here, and you can see that amount of space. We have to really zoom in now to see the part that's both extra and the part that's not filled in yet.
Yeah.
Keep going. Right? It's getting smaller and smaller.
And you can still see it. Here, wait, can I try zooming in?
Excuse me.
Oops. No, that was me. You can kind of see it, but you have to get in like really close. Here.
You have to get in totally close there.
Maybe if we can just align it perfectly, like this.
It's kind of interesting.
It's hard to see, but yeah. Kind of. You can see it like that.
We got 50 minutes left in the show. Do you have a sense of what you want to do next?
Why don't we match up what the actual volume is right.
You want to put it up here somewhere? Okay, let's do that.
I was thinking maybe right below this text.
Okay, can you do one favor for me though? See where it says new text up there on text calculated volume control?
Yep.
Can you change that to just, so we got to get an indication of what's going to go there?
Calculated volume.
Try a different integration method is actually putting us saying, well, let's hold on a second because, I haven't done integration in a while. While Campbell's working on that, I'm going to come over here and I'm going to learn about integration. How about interpolating the cylinders? I'm not even sure what you mean by that, Pudding. Integration. So like, hold on, putting something what to do. Instead of having them have flat sides, you have triangular sides.
What?
I don't think that's a thing we can do before the end of the show. And I'm not actually following how that helps us. I wonder if there's a consistent ratio you could use to calculate the proper inside area at the edges. Pudding says I need a drawing. Yeah, if we're talking about the cylinders having anything that's not flat, like they're coming out a bit or something like that, I'm not quite following that. I'm thinking it might be useful at the edge. Yeah, all right, let me switch back to Campbell's machine because he's making a little more progress on it. I was going to actually look up integration, see if we could learn a little bit about that, like how to create an integral, calculate an integral.
Duplicate. This is just volume.
Actual volume, maybe.
Real volume.
Yeah. So pop that on there and it's... Okay.
Real. Okay, and then...
Just move it down underneath calculated, maybe? And maybe change its color to red or something different so we're like, oh, okay. Just remembering it. As our goal volume, whatever. Okay. And then... yeah.
Real volume. Now it's time to write some code.
We only need to change this once. We only need to change it after in our start call.
Yeah. Hey, that makes it a lot easier. No. TXT.
Copy to the clipboard before you leave the line. You get down in line 31 there right after that and set it there. You can hit end and home keys. Don't forget those to help you get to the beginning and end of the line quickly.
Real volume equals...
It's dot text.
Oh, right. Dot text. Equals... interpolated string. Wait, and then here... braces. Oh, wait. Before, you have to say... real volume and then in here it is thirds times math dot pi oopsies, wrong thing. Math.pi times radius math.pi. Oh wait, no. Math.pi. Then here we say radius comma space 2.
Not 2.
Why
It's a
not?
volume, and so to get to the third dimension, we have to take a distance and multiply it by itself 3 times. 1, 2, 3.
Oh, by 3. Right.
It's a volume.
4/3 pi r
And you
cubed.
need something at the end of that line. Okay, you got it. Save it.
Save it.
Go connect that element to this script. Save, run.
Control S. Play. Do 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 do. Do 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 do.
So in theory, each slice would be something like total area plus equals square volume minus the circle volume times width. I don't know. I'm not a math guru by any means. Okay, we might have to make this maximize this so we can see the whole thing. All right, the real volume
Whoa!
is way off.
Way off, and I think it's the real volume, not ours. Huh, did I write that incorrectly?
I don't
There's
think you did.
definitely a
I didn't
chance.
see it. It's 4/3
Times pi r cubed.
Mm-hmm.
Design time.
Time. Ooh,
Was that you? Did you do that, Campbell?
nope. I don't think I did. I don't think I have that button.
So that's kind
oh
of
no, it could
interesting.
have been me, probably.
I just changed the operator order around. I put the divide at the very end. Funny says I can't find it. Let's try running it again. How do I send you a picture? I think there's a way to upload to like an image sharing place and give me a link to it. That's one way to do it. You can also send it to Mark M at DivExpress.com domain. Just throw a .com on the end of
Oh,
that.
that's much better.
Is it working now?
Yeah, that fixed it.
I put the 3 at the end instead of at the beginning. Divided by is what I did. Because I wasn't so sure about the operator order on that, and I wanted to get that. So okay, so cool. We got a real volume here.
It's getting more off. Just like
We got to
wait,
not a number
I got to not a number and then it got back.
as you went even higher. That's interesting.
Huh.
Yeah, it's interesting. It seems like there's a real limit to our strategy here.
But it feels fake.
It feels what?
It feels fake because we just went through it. Past it, if you will. Wait a minute. Now it's just not updating. I think I crashed it again.
Yeah.
No, it didn't. Okay, all is fine.
Okay.
Huh.
We got about, my calculations are right, we have about 40 minutes left in the show. We can, I assume we could switch to do something similar, but do it with the volume of the cone and see how we do go with that.
Okay.
I believe, if I'm recalling correctly, the formula for the volume of a cone is 1/3 of the formula for the cylinder itself. But we could basically stack up. So we could set some sort of height and radius and stack them up and calculate it.
Okay.
Based
Can
on
I
the
do
number.
something really quickly?
You sure can.
I realized that we have I don't want to call it a proximity flaw, because it's not really that, but here, I'll just show you. Wait a minute. I did that incorrectly. This, I want to be that.
You're gonna match the colors up. I love
I
it.
do.
You want colors to consistently convey information.
Yes. So now I think it will make more sense. Wait.
You got the image share working here.
Yeah, okay. So now it's just a bit more sense.
See what I think you mean. Oh. All right, here, let's take a look at what Pudding's suggesting here. So we're currently doing cylinders. The suggestion is to do these kind of angled cylinders instead. That's what we're talking about. I get the suggestion. I totally get it. That's going to be too advanced, I think, for what we're doing right now. For a couple reasons. We need to create it in Unity. I'm not sure exactly how to do it, and we need a formula for calculating that, which looks like it's kind of using the cone piece a little bit. There's a little cone kind of thing in there. The formula's easy. So the formula part's easy, according to Pudding. The multiples, adding all of those, adding that individual shape is a little tricky part. But it's also the same problem with not being fully accurate. You just end up flipping the inaccuracy. Yeah, I'm not entirely. I'm feeling like our inaccuracy is caused by something that's slightly out of our control. Is what I think. That's my feeling. At this point, it's total theory. It's tough to understand exactly why it's the case, because it doesn't happen until we're getting really, really close. So we've got a whole bunch of these elements that we need to add together. But theoretically, this should be working. This is the formula Pudding just giving us right here. I'll throw it up on the. So its radius 1 is equal to function of x displacement 1, and radius 2 is equal to function of x displacement 2. We got two different radiuses there, and then I figure there's some volume calculation you're going to give us too that you haven't given us yet. All right. So what I think I want to let's see. Do you want to? Let me ask you this, Campbell. Where are you? Do you want to go after? Let me calculate the volume. Now the problem is we can't really get those shapes in there easily as well. It's like it's a triangle. Yeah, I get it. So, Campbell, do you want to go after the cone? Hold on, let's see. Do you want to, or do you want to end the show, or do you want to do something else? Thanks, buddy. Sorry about that. It's like drawing a circle in a square. My thought was you could remove the extra fluff in the corner from your additions, but it's still just a slightly marginal difference. Interesting problem, though. Yeah, my thought is just as you get those thinner and thinner, right, the amount of error should be reducing. And that does appear to be true, for a few hundred. But then as we get, to a few thousand, it seems to change. Where are you right now, Campbell? What do you want to do? What do you want to do with your life, my friend?
Well, I definitely don't want to end the show.
Okay. What do you want to do between now and then?
Let's work on the cone.
The cone? Okay. Let's see. Blu-ray says, right, you do a 10 cylinders, I'm going to give you a circle anyway. Why try to be perfect? All right. So Campbell's going in, he's creating a brand new one. We're going to call this...
Buckle up, Buttercup.
That was me as well.
That was you. Okay, cool.
The other one was me as well. I just didn't know I did it.
I like it when we have explanations for what's happening. This is estimating the volume.
Oh, wait.
Estimating cone volume. Okay. You hold your hands out. You need me to give you a high five? You need my cell phone? Cell phone? No? You need my wallet? Oh, no, okay, that's the wallet.
Okay.
It just
How do
gets-
you like the new mic,
I
Campbell?
love it. It's great.
Yeah, it's much better, right?
Come on, load. Don't load. Ugh.
All right. So we'll throw down a more money. This is like a. Pudding says, "Hi, Mom. Please don't stop the show. We're having fun."
I'm not stopping the show. I'm just getting some money. It's $20 for every 15 minutes.
Okay.
I'm just gonna be quiet and let you run it. You tell us what you're doing.
Well, first I'm gonna add the axes.
Keep charging y'all. All right. We're gonna create the axis first.
And then do. Axes and that.
Well, you do that. I'm gonna start a PowerPoint, and I'm going to.
Oh wow.
I'm gonna create a drawing that shows us how we figure out the radius. By the way, real quickly, I'll jump over here. This is what we started with last week when we were building this. This is what we're trying to do.
Yeah.
So we essentially got it. We ran into that weird problem where it wasn't always getting more and more precise.
No, it was
But we think that
sometimes
might have something to do with some limitations of the number system, the data to hold the numbers
Wait a
that we were
minute.
using. There could also be a real, genuine phenomenon here that's occurring, but I don't feel like that's likely. Could be also a mistake in our code.
I remember when I was trying to crash Unity. Remember that? Yeah. It appeared I had a close up on the edge, and it appeared to be bouncing like back and forth a bit, like getting bigger, smaller, bigger, smaller.
That's interesting.
Now. X. Axis.
I'm verifying the formula for a cone. Formula,
Is
I believe it's 1/3. 1/3 pi r squared times height is what I believe it is. For a cone.
okay.
Yeah, it is 1/3 pi r squared times height.
Y. This one 0. Yeah. 90. 90. 90. Okay, finally. I'm trying to find out what the keyboard shortcut is for setting the camera position as the same.
As the same that you're seeing in the view.
Yes.
I'll look it up for you right now.
I can do. I'm doing it right now. How to. Oh, so you have to go to the key?
Did you find it?
Yes, I did.
What is it?
So, you select the camera. Wait. What's this button?
It says select your camera in the hierarchy and click Game Object Align with View from the menu bar.
Yep, but that's not the one. It's this here. No, that's what it's saying. Wait, but then what is it? Control Shift F. It says. Control Shift F. Nope, that does not work. Oh wait, I have to select my camera. Yeah, okay. Oh, it did work.
It's Control Shift F.
Yeah, I did that already.
You did it?
Yeah.
Did it work?
I just found it out. Yes.
Yeah, so Game Object is the main menu. It's up at the top. Do you see that?
Oh, yes, yes, yes.
So look at that. Select the camera, just so everybody can see that.
Yeah.
Yeah, that's what I
So
was looking at. So select your main camera.
If I moved to over here and I wanted to look down on it like this, and then I select my main camera, I could either hit Control Shift F, or come up here, Game Object, and Align with View.
Yeah.
And you can see Control Shift.
There it is, right there. Okay, cool.
Okay. And now. Ow. Oh wait, what is the formula for the area of a cone?
I'll show it to you. I'm kind of working on it over here. Working on getting a diagram out. This is not quite looking like a cone yet, so please forgive me. It's right here. It's pi r squared times height divided by 3. So it's basically, look, pi r squared gives you the area. Area times height gives you the volume of the cone, of the cylinder. And then you divide the cylinder in the third, and that gives you the cone. That's what you get. Okay?
Oh yeah, because there are three.
Well, I don't know. It's like it's you know, we'll kind of get there, I guess.
Because it's like you have two.
I can't real quite visualize how I can get 3 cones into a cylinder, but yeah, there's
It
something
would take
there.
a bit of squishing and squashing. But yeah, if you think about it, like if these are the 2 cones from the side, this is a cone right here. And then
Yeah, I can't quite get them all to fit in my head.
oh wait, I can see how 2 might make a cylinder.
Yeah, you kind of see what I think you see what I'm getting at here. It's a little tricky.
No, 2 wouldn't. 2 would be close, but. Wait, no, 2 would. But then where's the third one? It's just like true. 4. You know what's fun? We're using cylinders to calculate the volume of a cone, but we could also use cones to calculate the volume of a cylinder.
Kind of, but with the cones, it's hard to like stack them up in a way to fill it, to fill it all up. But with cylinders, we can totally visualize that.
Something more cone-like.
Oops, I just realized I've been showing mine the whole time, so your screen. There you go, Campbell.
So this code, I think, will be very similar to the circle code.
Right, there's a lot of similarities between the two.
With the
There is. We definitely need a prototype, slice. We need to be able to create it. It's almost like we could take the other app and modify it, right? To be able to support either a cylinder or a
cube.
or a sphere.
What?
Are you saying what to me?
Yeah, you said a cylinder or a sphere?
Yeah, so we could take the other one where we're saying, well, we're trying to, I'm sorry, cone or a sphere. That's what I meant.
Okay, that was a bit confusing. Later. And that might be easier, actually. No, that's not it.
All right. Can you also, while you're working, can you tell people what you're doing?
Oh
people
yeah,
understand
sorry.
what's
So
happening?
right now I'm just trying to get it so that the middle of the axes is in the middle of your screen.
From the camera. Is it, if you looked at all those axis points are already at 0, 0, 0 in terms of their position?
Yeah, I'm just trying
Is
to
that
get
true?
the camera into the right position.
Okay.
I would definitely say so. Let me see.
Can you tell us what you're doing, Campbell?
I'm just still trying to get the camera into the right alignment.
Okay.
Okay. Now I'm creating the prototype slice. Slice. Prototype. You want to go? Okay.
What are you doing now?
Trying to get it super slice-like.
Okay. So you're creating a slice prototype?
Yes.
Cool.
And then, like, I'm gonna rename this to game logic so that I can. It's easier to be linked up with the code, or you know that it's linked up with the code. So we're gonna need a slice count. And probably also, well, all of these, but a slice prototype. And something similar to this, where we have a cone. Oh wait, no. 1, 2, 3. Control V. Control C. Tab. Control V. Oh, diddy-do. Now I'm gonna create the outline for it, for the cone.
Oh, because we have to create a cone.
We do.
Yeah. Somebody says he thinks you need a nap. Kevin woke up this morning and said he had good sleep last night.
I did.
He did.
Control A. No, I did. It was Shift A. Back.
I feel like there was a plugin or something we added to give us cones inside of.
Oh, well, that was easy. Oh, there was. It was a code.
It was a plugin we added. Yeah.
It was a script. Sorry, not a code.
It created a cone for us.
Script, and it created the cone.
Okay, but we're going to use this. You're in Blender. We're going to create this instead. Okay.
And it was really easy. There's just already a mesh for a cone in
Okay,
Blender.
and then we can export this and bring this in. Do you
Yep,
remember how to do that? Because I do not.
I do.
Let me show you what's going on my machine over here. I've got my drawing set up here. These are the different slices. We'll figure out this number of slices just like from our slice. We'll figure out the number of slices. That'll determine our slice thickness and how many of these are. And then I created this formula, which I think is correct, which figures out the radius for any of these individual slices, like the radius of this one, is going to be the radius of the cone times this, which basically gets me kind of a this kind of linear interpolation based on my height right here. So it's the height of the cone minus my y position. So if my y position gets really close to the height, this number on top is going to be close to 0.
Very similar to the x position that we had, that variable. But because remember, we were using minus x position to determine the radius as well.
You're talking about in the sphere?
Yeah, for the sphere, and because it was just, kind of...
With that, we had a formula based on the x position. This only varies based on the y position, because I'm going to stack it up vertically.
It's flipped, kind of, because the sphere was pretty similar to 2 cones, just put together.
All right, so that's what I'm working on. Back over to Camel's machine. What are we doing next?
Now I am creating, well, wait, what am I creating? Oh yeah, I'm importing the cone. My files. I should probably name that. Can I rename it from here or no? And all we want is this. And it has that weird material in it. Cone. Oh wait, it really is kind of fun. Create
I'm going to give you some methods here. I'm looking at methods over in our old game logic that we can reuse. Because the logic's similar. Since we're starting a new project here.
Yeah.
Next time you're over in game logic, let me know and I'll come paste them in. We'll modify them when you're ready for it. So I want to be able to specify the height of the cone and I want to specify the radius of it. When I make those changes, then I want to see this visualize those changes, whatever those are. We should probably get that working first. We got the rotation. Negative 90 or 270.
Wait, oh yeah, it is 270. Not 180. Don't know why I put 180. Nah, bigger. 10.
So your X and I think your Z are always going to be the same.
Control C. Tab Control C. No, everything's gonna be the same.
No, I think the height is Y. It's going to be different.
No, because in Blender, 111 was the right thing. Here, I'll
Right, but I want to be able to
show you.
stretch out the cone. I want to have a cone of different height.
Look, that is of different height.
Right. Well, now I want to be able to change Y. What I'm suggesting is the height is determined by the Y scale. Just try it. Change Y to 20.
Okay, but it's gonna look weird. Oh wait, we rotated it, so it would be Z, I think.
I think it was we need to change the orient. Oh, okay, cool. All right, cool. So X and Y are going to be the same. Z we're going to change. When we change Z, I want the base to always be at the zero, at the origin. So what do we need to change in the position when we make Z 20 to make that be true?
It would have to be 10,
Try it.
I think.
No, Z. Yeah. See what happens. Nope, it's not Z.
It is Y.
Try it. Bet you're right. Y feels better to me. But it's not 10. Try it at 20. What happens when we make Y 20?
20?
Wow.
What?
That's surprising. That does not behave like I'm expecting, but
No, that doesn't.
but at least we know this is how it's going to work with this. We can make the visualization work. The only thing that's important is to make it work. I think
Blender it uses different systems than Unity, so important.
maybe that's it. Try just to double check. Let's make it 30 and 30.
30. Looks like it is gonna work.
Yeah, I think what it is the origin of this shape, Campbell. The anchor point for this shape, its 0, 0 coordinates are at the base. Whereas in Unity, when we drop a shape, its origin is in the center of the object, that anchor point.
I think it's flipped actually. It's in Blender, it's at the base, whereas in Unity, it's.
That's what I think I just said. But okay, cool.
You said it flipped, and it's pretty much the same thing.
Okay. All right, cool. So we've got a way to visualize now with a cone. Good job. And do you have a transparent, does it have a transparent material on it?
Yeah.
Okay. I got something that says untitled there, or that's just the imported cone?
Yes.
You don't need to worry about that. Okay.
I actually think I can delete this. No, I can't.
All right, let me make some changes. What's this?
That's all. I deleted it.
Oh, okay. Next time we save that, we should not save it as untitled. We should save it as give it a
Yeah,
good
I
name.
know. Wait, where is this here then? Can I delete this? But I can't. But this is. I'm so.
Why don't you delete everyone and export it one more time?
Delete
Now
everywhere.
export it one more time. Now get rid of that. Export it one more time so it's got a good name. You just practice that. What's interesting here is I was theorizing that the 0 point was in the bottom of it, but it doesn't look like it. The origin looks like it's right in the middle, which is bizarre. But I guess on the export, maybe it makes that happen. Call this cone. That's making me happier. And that blend. Okay. Import.
import new asset.
See how much easier it is to find it, right? You don't have a whole bunch of untitles in there. All right, cool. Now it says code inside here. Good.
Oh, I should have copied the component.
There's 2 codes up there.
What?
The old one, wait. The old one has the values you want.
No,
Look.
it doesn't.
Yes, look. See,
Then how do-
copy the transform and paste it down.
These are...
Now go down to cone and paste it in there. Is there a right click option? Paste component value. See it? Good, and get rid of the old one. Good. Not too bad. That didn't take too long to fix that.
Not too
All right.
shabby.
Okay.
Alright.
Ready to go to game logic? You get some code?
Mm-hmm.
Or no? Yes or no?
Yes.
Okay.
I was
Here we go.
trying.
I'm not sure if we need. Hold on, give me control for a sec. I don't think we need to start. I guess I'll keep the start.
We do,
update. I
right?
don't think we need the update. Really, it's not taking one ahead of the clipboard. Let me try again. Copy. Bring it over. Paste. There it is right there. Okay.
Ooh, that's a lot.
These are methods that we had from before. Do I have update already in here? I do have update. So we get rid of this. So we have this killer destroy previously graphed slices. We need to create a constant up here. Call it live slice. You're going to need to create a tag with that name right there. Doesn't understand math, that's square root here. Let's go make sure we've got the right system. We need to use the system. Now this is using that code I'm deleting right there because that was using the old code. That was using the old code for figuring out where to put it in the sphere. Okay.
Oh, yeah.
It's going to be like calculate cylinder diameter, and we'll do this, and it's Y position, I guess. So instead of X position, it's going to be Y position. So add cylinder, maybe we'll rename this to Y position right here. And create slice. Before our slices were like this, Campbell. Remember?
Yeah.
We're going to do them this way now. We'll stack them up
Yes.
that way. I'm just going to set this equal to 10 for now, but we've got this to do. Calculate that. The Y position is going to be passed in. It's not that, it's radius. Like this. We're passing in radius squared. I don't even think we need to pass it in.
Wait, I thought it was diameter.
What?
I thought we needed the diameter for the equation.
We need for each cylinder we need its diameter, its thickness, and its position. So we need to calculate cylinder diameter or its radius.
Oh, okay, and radius. All right.
And oh, I'm sorry. When I said radius, hold on. Right, that was wrong. I'm wrong here. So the cylinder diameter. I guess I just need only the cylinder diameter. Let me get that Y position. Let's go look at the calls to this. We need a variable called need to rebuild. Let's add that. All right. We have this radius property right here. Let's make it a float. And there's our radius. And diameter. We're going to come down here and say it's going to be a read-only float property. And diameter, and we're going to return radius times 2. We now have diameter. And we need this. Can you add a text slice count on there for me?
Yes.
And then we need to add cylinder.
Do.
We only got 3 minutes.
We only I'm not gonna finish.
We'll stop it here and we'll continue maybe tomorrow. I don't know. We're back tomorrow. Maybe we'll find out. So let's close down that Skype window. That little Skype window that's blocking the transform.
Gotcha. And then name of the engine.
Dot UI, I think, right?
Yeah. Dot UI.
Okay. Then we need to create a new text object up in around line 13 or so.
Variable. We don't have one for text.
Nope, we do not. Hit undo on that. Let me show you something that happened. See this? Push added that because I thought you wanted a thread.
Oh.
So undo and now it goes away automatically there. No, we don't. But we can do this. We can duplicate like this, and you could say, okay, whatever it is it on the clipboard? Yeah, text slice count. Come over here and just type in text. And that's how you can get that quickly. That makes sense? I can duplicate something that isn't the right type and just change it to the type I want it to be.
And public.
And I think we're like running out of time on the show. Do you want to keep going, or what do you want to do?
We should probably stop.
Stop, you said?
Yeah.
Okay. So we got to fix that. So let me put a to-do right here. Fix this. Kind of left off here. I do this sometimes when I'm writing code, Campbell. I'll put a to-do right there.
That says left off.
Yeah. This is where I need to do to come back. Let's see. Let me get it right gone. And thanks so much for being with us. Are we coming back tomorrow, Campbell? Do you know? What's your...
Yes, I think we are.
You think we are. So I think we'll be back tomorrow. All right. And so we'll finish this up tomorrow, and if not, we'll see you on Friday. Code It Live. Code It Live's got some interesting stuff. We'll send you over to Code It Live.
Okay. Goodbye. See you tomorrow, Friday.
See you tomorrow, kids. Thanks so much.